My dear disciplined students, today I have to teach you about the preparation of haloalkanes and haloarenes. So, first of all, in this topic, you will learn the preparation of haloalkanes from alcohols, not haloarenes. The preparation of haloalkanes from alcohols. So, see here, this is about the preparation of from ethanol. So, by the action of halogen acids, when ethanol reacts with halogen acids, as for example HCl, HBr, HI generally, it forms haloalkanes in the presence of zinc chloride. In the presence of zinc chloride. So, see here, this is zinc chloride here in the presence of zinc chloride. Ethanol reacts with HCl or HBr, and this rectangle, in this way you have to learn. The rectangle takes OH from alcohol and H from HCl, and it forms haloalkanes. And this is about the second reaction, this is about the third reaction in this way, and also this is about the reaction with HBr, heat, Conc(H2SO4), and this is the reaction between ethanol and HI when it is refluxed and it is heated. Reflux means when the reactants are heated in a flask, and after evaporation there is a condenser is fitted in the flask, and with the help of this process, when the preparation of any compound is done, that is known as refluxing. The process of refluxing, here iodoalkane is prepared, iodoethane. But remember, very important is that secondary and tertiary alcohols are not used to prepare iodoalkanes or iodobromanes, because tertiary alcohols on heating with Conc(H2SO4) undergo dehydration from and to form alkenes. Means secondary and tertiary alcohols undergo dehydration when haloalkanes are prepared with this process, means in the presence of Conc(H2SO4) when it is heated. Because you know very well that in class 10 you already learned that when ethanol, in the preparation of ethanol when heated at 160 degrees C in the presence of Conc(H2SO4, it forms ethene. So that's why in the case of secondary and tertiary alcohol, the formation of carbocation takes place very rapidly, and in the carbocation rearrangement, with the help of rearrangement, alkene forms. In chapter alcohol, I will teach you about the mechanism of the preparation of the alkene from alcohol by the action of Conc(H2SO4) on heating. Now, so that's why it is written that secondary and tertiary alcohols are not used to prepare iodoalkanes or iodobromanes, because tertiary alcohols on heating with Conc(H2SO4) undergoes dehydration to form alkenes. Now, about the order of the reactivity of halogen acids with alcohols is in the order: HI is more reactive than HBr, HBr is more reactive than HCl. Why? Because bond dissociation enthalpy increases from Hi to HCl. That's why Hi is more reactive. Now, reactivity of alcohols is in the order of third degree, second degree, and then 1 degree. Means tertiary alcohol is more reactive than secondary alcohol. Secondary is more reactive than primary. Reason: because stability of carbocation formed in the transition state decreases in the order third degree to second degree to first degree. That's why it happens. Now on the second page, very important, that it is very difficult to obtain neopentyl chloride from neopentyl alcohol because the reaction occurs through the formation of carbocation. The neopentyl carbocation 1 degree formed rearranges to third degree carbocation through 1,2-methyl shift product. So what is 1,2-methyl shift? See here, with the help of this you can see that 1,2-methyl shift. What happens when OH gets removed from here? It forms carbocation, and in this case the methyl is just beside of this positive carbocation. So this methyl gets shifted on it and it forms tertiary carbocation. So now chlorine will attack at this position. That's why it forms 2-chloro-2-methyl butane. So in place of neopentyl chloride you will get 2-chloro-2-methyl butane. Same facts happens in 1,2 hydride shift, only in place of methyl it is hydride, and so on. Now on the third page, by the action of phosphorus halide on alcohol, so simply in place of OH, Cl gets its position, and 1 Cl of PCl5 comes in the form 3 Cl of PCl5 comes in taking 1 oxygen from alcohol, gives product POCl3, and the remaining Cl, because there are 5 Cl atom is here, 1 Cl is obtained in the form of ethyl chloride, 3 Cl in the form of POCl3, and 1 Cl in the form of HCl, in the form of HCl. So it is clear from the product here, HCl. Now by the action of thionyl chloride, SOCl2, same type of reaction takes place. In place of OH you will get Cl, and 1 Cl remained, which comes in the form of HCl, and O of this OH gets attached with SO of SOCl2, and it gives SO2 here. See here, SO2. So in this way, from hydrocarbon, from alkanes, simply very simple reaction. Already you have learnt in class 10 and also in 11 that reaction of halogen with alkanes in the presence of sunlight. So simply it takes place with the help of free radical substitution reaction, and you will get the product like this. But remember, in this situation mixture of haloalkanes are obtained because so many hydrogen atoms are attached with the hydrogen. That's why mixture of haloalkanes are obtained. But the nature of the halogen and the number of type of hydrogen being substituted, it depends upon this fact. In general, the ease of substitution of various hydrogens follows the sequence third degree to second degree to first degree. So this one. Now on the fourth page, haloalkanes and haloarenes substituted from are prepared from. Now this is preparation of haloalkanes from substituted benzene and alkene. The substituted alkene may be of two types. One is vinyl, another is allylic. And substituted benzene will be of two types. One is benzylic, another is allylic. So see about the reactions here. Benzylic is more reactive than allylic. Benzylic and allylic are more reactive than allyl. Allyl is more reactive than vinyl. Vinyl is more reactive, and vinyl and allylic radical are same in the category of the reaction. The high reactivity of allylic and benzylic hydrogen atoms can also be explained in terms of stabilization of the allylic and benzylic free radicals. Means that in this the reaction in this process takes place with the help of in the presence of light, and I mean to say that the alkyl derivative of benzene and the alkyl derivative of alkane will react with chlorine in the presence of sunlight or any other reagent with the help of free radical substitution reaction. So, what happens in free radical substitution reaction? First, free radical forms. And you know that secondary, tertiary free radical is more stable than secondary. Secondary is more stable than primary. That's why if the radical formed gets stabilized through resonance, then this reaction takes place with fast speed. Means preference will be given to such type of reaction. Means that's why benzylic, because benzylic radical, free radical gets stabilized through this resonance structure, and allylic radical gets stabilized through these two resonating structures. That's why these free radicals form quickly, and if the formation of free radicals, the ease of free radical, the more is the ease of free radicals, formation of free radicals, more will be the speed of the reaction. That's why it is written here in this case, and with the help of these reasoning structures, it is very clear. Now on the fifth page, from alkenes, very important, addition of HBr in class 10. It is the matter of class 10 and 11. The addition, the properties of alkene with reaction of alkene. In the properties of alkene in class 11, you would have learned that addition of HBr on alkene. But the addition of HBr on alkene will take place through Markovnikov's rule, and alkenes are of two types, that is symmetrical and unsymmetrical. In the case of symmetrical, there is no problem, but in the case of unsymmetrical, Markovnikov's addition rule is followed, and you know that in what happens in Markovnikov's addition, the negative part of the HBr, that is Br minus, will go to the carbon atom which has least number of hydrogen atom. So in this case, the Br atom will attack on this carbon atom, on the middle carbon atom of propane. But when peroxide is used, in the case of peroxide, that is anti-Markovnikov's addition, in the chlorine atom will attack on this, means on the first carbon atom of propane, and it will form one bromopropane. So if you want to get 1 bromopropane from propene, then with the help of anti-Markovnikov's reaction you can get. So this is about the mechanism of the anti-Markovnikovs. So what happens? See here, mechanism. When you will see the mechanism in PDF, you will understand it. It is not very difficult. Simply with the help of this reaction you are clear, it will become clear that see here what happens. So secondary carbocation forms and HBr gets attached with this carbon atom and you will get Br, 1 bromopropane in this way. 1 bromo major product will be obtained in this case. And it is clear, you can understand this with the help of this mechanism. See here, in the case of benzoyl peroxide, it forms this type of radical which comes in the form of 2 phenyl radical. Phenyl radical phenyl free radical reacts with HBr through homolytic fission of HBr, and you will get one product is benzene, other is Br free radical. Br free radical attacks on propene and one product is 1 degree free radical here, another is 2 degree free radical. So 1 degree free radical is less stable and here is 2 degree free radical. So on this page this is about the 2 degree free radical. 2 degree free radical again reacts with HBr and gives its 1 bromopropane. Now addition of halogen only. So there are 2 bromine atoms, they will give the addition product, means 2 bromoethane. From alkynes similar is the case. At triple bond they will attack and you will get this type of compound. And if you want to get from ethyl chloride ethyl iodide, you can follow this type of reaction, and this is known as Finkelstein reaction. So remember, it is asked in the topic name reaction. So remember it, very important, Finkelstein reaction, and you have to make a notebook, separate notebook for the name reaction, for the conversion. So in this way I taught you today about the preparation of, mainly about the preparation of haloalkanes or the halo derivative of alkyl benzene and alkyl alkene. Thank you.